The James Webb Space Telescope, known to many simply as Webb, has once again proven why it's considered one of humanity's most powerful scientific instruments. With its cutting-edge infrared vision, it has managed to detect a remarkable celestial body, a super-Earth that could support life. This planet, located just 40 light-years away in the TRAPPIST-1 star system, sits comfortably within what astronomers call the habitable zone, an area around a star where conditions might allow liquid water to exist. That alone makes this discovery worth celebrating. But there's more. It's not just the water, but also signs of a potentially life-friendly atmosphere that are turning heads. This super-Earth, larger than ours in home planet, but not quite as massive, as gas giants like Neptune, presents a whole new category of world. Scientists describe it as rocky, with a mass up to 10 times that of Earth. These types of planets offer something of a sweet spot in size and structure, giving them enough gravity to hold onto dense atmospheres, an essential trait for sustaining life. What makes this find even more exhilarating is the data collected from Webb's powerful spectroscopy instruments. They've identified traces of water vapor, methane, and even hints of oxygen in the planet's atmosphere. These are chemical fingerprints often associated with biological activity here on Earth. TRAPPIST-1, the host star, is an ultra-cool dwarf that's smaller and cooler than our Sun. It supports 7 rocky planets, 3 of which, including this, super-Earth, are in that precious habitable zone. Scientists have long been fascinated by this system, but this particular world is now considered its shining jewel. Despite the challenges it poses, such as being tidally locked, meaning one side always faces the star while the other remains in darkness, it offers intriguing possibilities. That permanent day and night divide might sound hostile, but if the atmosphere is thick enough, it could act like a planetary thermostat, redistributing heat and creating a stable twilight band, what scientists call the terminator zone, where life could find a foothold. The potential presence of biological markers, biosignatures, is what really sets this planet apart. The unusual combination of methane, carbon dioxide, and possibly oxygen doesn't easily fit with non-biological processes. While volcanic activity or chemical reactions could explain these signs, the specific ratios suggest something more. Something alive. On Earth, such atmospheric quirks are usually the work of microorganisms or plants. These findings may not be concrete proof of life, but they're a very strong nudge in that direction. Water, often dubbed the elixir of life, is central to this story. Its detection in vapor form points to a chance that the planet could possess liquid water on its surface, or perhaps even vast hidden oceans beneath the crust. If the surface proves too extreme due to the planet's light and dark halves, life might still exist below, in subsurface aquifers, much like the extremophile organisms found in Earth's deep caves and undersea vents. These life forms thrive without sunlight, relying instead on chemical energy, proof that life finds a way in the most unexpected places. Of course, this planet isn't without its hurdles. The tidal locking creates extreme temperature contrasts that could make some areas uninhabitable. But again, the idea of atmospheric circulation softening those extremes provides hope. This dance between light and shadow could drive the evolutions of truly alien life forms, perfectly adapted to their strange environment. It's a vision that fires the imagination. Creatures molded, not just by biology, but by the very rhythm of their planet's split personality. None of this would have been possible without the James Webb Space Telescope, a technological marvel that's pushed the boundaries of space observation. Its ability to detect the faintest chemical signatures across unimaginable distances has redefined how we study other worlds. And this is just the beginning. Future missions, both in space and on the ground, are being designed right now to build upon Webb's discoveries, bringing us even closer to unlocking the secrets of this super Earth. Back on Earth, scientists are diving deep into the data using artificial intelligence and machine learning, pulling out even more insights about this planet's surface conditions and atmospheric dynamics. At the same time, visionary projects like Breakthrough Starshot are exploring new ways to reach these distant stars. Maybe not with human travelers just yet, but with ultralight probes powered by laser sails that could make the journey within a few decades. This surge of discovery and innovation has reignited the public's passion for space exploration. Governments are upping their investment in exoplanet research, and people around the world are tuning in to learn what's next. As scientists focus on tracking gas fluctuations, looking for patterns that could mirror the seasonal cycles of life here on Earth, excitement builds with each new revelation. Perhaps the most thrilling part of all this is imagining what life might actually look like on a planet so different from our own. Higher gravity could produce stockier, more muscular creatures. A thick atmosphere might blur the skies in ways we've never seen. Evolution could take paths that defy everything we know, resulting in ecosystems that are completely alien, but still profoundly alive. And this brings us to one of the biggest, most profound questions of all. What do we do if we find intelligent life out there? The discovery of a potentially habitable world like this one reignites that age-old debate. Should we reach out? Would they welcome us or fear us? Some scientists argue that contacting an advanced civilization could unlock answers to mysteries we can't solve on our own. Others, like the well-known physicist Michio Kaku, warn that we might be revealing ourselves to a species with motives we can't predict. The Webb telescope's findings push this conversation from science fiction into the realm of very real decisions. Ultimately, this super-Earth discovery isn't just a major milestone. It's the beginning of something much bigger. We now have a target, a real place that could hold life. That reality demands not only better technology, but also a united vision. We're on the edge of a new era in human exploration, one where we're not just observers of the stars, but active participants in the search for other worlds, and perhaps other civilizations. This isn't the end of the journey. It's the launch pad for what comes next.